Hello everyone, my name is Tina and today I am your teacher cum dost is here to teach you a very good topic, that is of the atomic mass. This concept is very important for you guys because this concept is the basic concept which is required by you if you want to enter into the field of chemistry. So let's get started. So guys, today the atomic mass with which we are going to deal is that atomic mass which is presented in the periodic table. We know the periodic table is what? Periodic table is a table which consists of the elements along with the atomic number and atomic mass. Okay, so atomic mass, if you see in the periodic table, is not represented in the form of the kg. It's represented in the form of the U, AMU or the Dalton. This is the way of representing the atomic mass there. So how that atomic mass came and why it is written like this, why it is not taken in the form of the kg, we will see here. Okay, so first of all, in order to understand this fully the term of atomic mass, first of all we have to understand what is the meaning of mass, what is the meaning of an atom, and then we will collectively understand what is the meaning of an atomic mass. So what is the meaning of the mass? Amount of matter present in the substance. So we know that everything which is present in our surrounding is made up of what? It is made up of the matter. So amount of that matter present in the substance is represented by its mass. Okay? And what is the SI unit of the mass? Its SI unit is of the kg. Okay. Now we will see what is the meaning of an atom. Atom, we can say that it is the smallest unit of the matter. The smallest unit of matter is atom. The smallest unit of matter is, we can say that, the atom. Atom, we can't say the smallest indivisible unit of the matter because we know that atom consists of the subparticles called, subatomic particles called proton, neutrons and the electrons. So in order to understand this meaning of atomic mass, I will show you first the diagram of an atom and then we will deal with what is the meaning of an atomic mass. Okay, so we know that an atom consists of a nucleus at the center and around that nucleus there are electrons which are revolving around this, and this nucleus consists of two things, that is the neutron and the proton. Neutron and proton, from which this nucleus is made up of, and around this nucleus electrons are revolving. One thing which we have to consider is that most of the mass of the nucleus, as also told by the Rutherford experiment, is presented inside the nucleus. Mass of electron is very small. That's why when we consider the mass of an atom, we will not consider the mass of electron. We will just neglect them. Okay. Now we will see what is the meaning of an atomic mass. Now it's very clear to you guys. Atomic mass, the mass of an atom is called the atomic mass. Now, in order to understand how that atomic masses which is present in the periodic table came and why it come, we have to understand further two terms. So until now what we have done, or what we know is what is the meaning of an atom, what is mass and what is atomic mass. We have understand these terms separately very clearly. Okay. Now come to this thing. Another term, relative atomic mass. Since now we know the meaning of the atomic mass, we have to understand what is the meaning of relative. Relative actually as compared to. For example, if I say I bring a very beautiful picture in the class drawn by an artist. Okay, and I told you all the guys to make that picture on a drawing notebook, and the criteria of deciding which picture is better or which picture is best is on the basis of the picture I have brought to the class. That is, I will compare your picture with the picture I have in order to give the number or marks, or in order to give remarks to a picture, a better, good or best. Okay, so we can say that this picture I have brought to the class and act as a reference with respect to which you all work, so that you can get the good marks or good remarks, we can say that. ठीक है ना? So relative means as compared to. Why this relative atomic mass is required? Actually, the mass of an atom is very small. It is around 10 raised to the power minus of 27 kg. See how much small is this term? 10 raised to the power minus 27 kg. If I try to represent this, it will be like 27 zeros I have to report it. Is there any weighing balance that can measure such small amount of mass? I don't think so. So that's why it is difficult to measure the mass of it is very difficult to measure the mass of an atom. So what the scientist does, they actually determine the mass of, although it's difficult, we know that scientists will manage everything, and that's why chemists are always famous. They will make impossible thing possible. Actually, ठीक है? So they find out the mass of an atom of a particular element, and they find out actually the mass of the element 12C. And after determining its mass, the mass of the other elements, atomic mass of other elements, will be decided by comparing with the mass of the element which they have determined. So rather than calculating the atomic mass of each and every element, what they does कि उन्होंने एक 12 कार्बन का atomic mass find out किया, and after that they find out, after that rather than finding out the mass of other element, they compare the mass of those elements as compared to this and calculate the relative atomic mass. How this problem, and via this the problem of getting atomic mass of each and every element get easily solved. Now there is no need to find out the atomic mass of each and every element. I will compare the masses of that element with respect to 12 carbon, and I will get a atomic mass. In order to further understand this thing, let us understand how this happened. Okay, now this 12 carbon atom is atomic number is 6. We know that the atomic number represents the number of protons or number of electrons, and atomic mass represents number of protons plus number of the neutrons. Okay, so this 12 carbon atom, I will slightly rub it here. So this 12C carbon atom consists of 6 protons, 6 neutrons and 6 electrons. Okay, and the mass of it was find it out by the scientists come out to be 19.92 10 raised to the power minus 27 kg. This is the mass which they have find it out. Now I say that already the mass of the electrons is very negligible, so I will remove it. Although it contains the mass of the electrons as well, but mass of electron is very negligible. So in order to get the value of an average, that is what is the mass of single particle, I will eliminate it. Okay, so also we know that the mass of the protons and neutrons are almost identical. So I can say that the mass of the 12 particles is equal to 19.92 10 raised to the power minus 27 kg. So mass of one particle is equal to 19.92 into 10 raised to the power minus 27 kg divided by 12, and try to find out what it come out to be. It come out to be, let me write it here as well, 1.66 into 10 raised to the power minus of 27 kg. It's come out to be this. Okay, this is the mass of the one particle that we are going to deal with. So shall I think I should rub it in order to make you understand further things. So this is the mass of the C12. No, this is the mass of the one particle, or we can say that this is the 1/12th mass of the carbon atom. Why is it 1/12? Mass of 12 particles is equal to this. So mass of one particle come out to be this. So 1/12th mass of the carbon atom is find out to be this. And this 1/12th mass of the carbon atom is called 1U or 1 AMU or 1 Dalton. Further understand this concept, first of all I will rub it. So until now what we have known is the mass of 12 carbon atom is 19.92 into 10 is to the power minus 27 kg. Mass of 1/12 of the 12C carbon atom is equal to 1.66 into 10 is to the power minus 27 kg, and I say it is a 1 U, 1 AMU and 1 Dalton. I think now you guys can slightly see from where this U come. So U means unified mass, AMU means atomic mass unit, and Dalton is for the name of the scientist. So 1/12 of the mass of the carbon atom will be defined as 1 U. So now the mass of other elements will be determined, or we can say that will be represented as compared to this mass. In order to understand this first, this related term, I will give you an example. For example, there is a girl, Paheli, and there is a boy, Bujo. Okay. So, the Paheli has 20 toffees and Bujo has 10 toffees. If I ask you how much Paheli toffees are higher than Bujo, what will you do? You will do 20 divided by 10 is equal to 2. So what you does is, you have divided the toffees of Paheli by that of the toffees of the Bujo. So this is a relative term. This two is relative terms. We can say that the number of toffees Paheli has is 2 times higher than Bujo. So I can directly write this thing. In the similar way, scientists report the atomic masses of other element as compared to this 1/12 mass of the carbon atom by representing how much that particular element atomic mass is higher, or it will be always higher because it's a very small term, higher than 1/12 of the carbon element, and that will represent our relative atomic mass. Okay, so for example, if I say sodium, sodium has a mass of 23 AMU or 23 U. It's 23 AMU. It means the mass of sodium is 23 times higher than 1/12 of the mass of the carbon atom. So now we come up with the formula of relative atomic mass. So by relative atomic mass, it is not required to calculate the actual atomic mass. We will now consider the other atomic masses by comparing it with the 1/12 of the carbon atom. We will represent the relative atomic mass, not the actual atomic masses. Okay, so now I will write the actual formula of relative atomic mass. So relative atomic mass is the mass of atom, and it will be represented in kgs as well. Mass of 1/12 of the carbon 12 atom. This is one formula, or I can say that the mass of an atom to the mass of C12 atom into 12. So now it is not required to represent very small masses of each and every atom. It's in the order of 1.66 or 19.92 to 10 to 27 kg. We can represent in the whole number form like this. Okay, one thing we have understand, the relative atomic mass is represent how much a particular atom is heavier than 1/12 of the mass of the carbon atom, by which it is found out to be the relative atomic mass. Now another meaning of relative atomic mass is that it is the mass of the one particle. One particle mass is equal to 1.66 into 10 to the power minus 27 kg. So if atomic mass, if mass of sodium is come out to be 23 U or 23 AMU, I can write like this, then it means sodium consists of total 23 proton plus neutrons. So number of protons plus neutrons come out to be the 23. So this is relative atomic mass. So one problem of U has been solved in case of atomic masses. And also we know with the help of atomic masses, we can get the number of the protons plus number of the neutrons. So relative atomic mass solved our two problems. So now add some more things in the list what we have now, and it's congratulations to you guys that you have learned more topics. Okay, so now we know what is relative atomic mass. And relative atomic mass is mass of atom divided by mass of 1/12 of the carbon 12 atom. This is, we know that it's a relative atomic mass, and what relative atomic mass tell us, it tell us आपके पास में how much an element atom heavier than C12 carbon, no C12, 1/12 of the C12th carbon atom mass. And second thing, it will tell us the total number of neutrons plus protons. These are the two things by which we get to know, that is how much an element is heavier than 1/12 of the C12 mass, or total number of neutrons plus protons. These are the two things that we get to know from relative atomic mass. So I think you should know how much important term it is. Now, another thing that we have observed in the periodic table is that the atomic masses which is represented in the periodic table is actually in the form of decimal number. But how is it possible? If I say that it represents the total number of protons plus neutron, then it should be in the form of the whole number. And if we see the periodic table, the masses are represented in the form of the decimal. Is it possible to have a fractional number of the neutrons plus protons? No, it is not. So why it coming in the form of the decimal? So the answer of it come from the another term which is called average atomic mass. So in order to understand this thing, let's take an example. The mass of the chlorine is found out to be 35.5. All we know that it's 35.5. Similarly, the mass of the rubidium is found out to be 85.5. Actually, it's 85.5. So the mass of the rubidium come out to be 85.5. That of the chlorine, let me write it in a bigger so that you can understand this thing. 35.5, rubidium 85.5 around, it's come out to be the mass आपके पास में इसके अंदर से, 85.5 rubidium. Let's not talk about the atomic number this time. Okay. So how these terms come? It means that there are fractional number of protons or neutrons. No, actually not. Actually, along with this average atomic mass, you have to understand one more term, isotopes. In nature, for a particular element, isotopes exist. What are isotopes? Isotopes are those which have different top. You will think what is the meaning of a top? I will make you understand. Okay. So, what is the meaning of an isotopes? Isotopes actually are those species which have same atomic number but different mass number. And we know that when we represent an element, it is represented on the top, the mass number, and atomic number represented it down like this. This is atomic number and this is mass number. So those elements which have, or those species which have same atomic number but different mass number are called what? They are called the isotopes. Okay. So I should rub this thing. I think you should know these things now, because I make you understand all these things properly. So इनका same atomic number होगा लेकिन different mass number होगा. Example we can take that, and they are very familiar example. Actually, I think maybe you know. One is for the chlorine, and it's for the carbon, and for the hydrogen. So I will now rub all these things that we know, that relative atomic mass, mass, and atom. Now we will get to know the average atomic mass. At last, I will sum up all the things so you to get it properly. ठीक है ना? So example of isotopes. Example like hydrogen, deuterium, and tritium. It will be represented like this, or we can represent it in the form of the H as well. There is no need to write D or T, we can write H as well. Okay. So it will be 2, 3, 1, 1, 1. So they all have, so we can see that they all have the same atomic number, but they all have different mass number. Another example is of carbon, let's say chlorine 17, and this 17, 35 and 37. This is another example. So these are the example of isotopes. Now, why there is a need of average atomic mass? Actually, in nature, all these isotopes exist. Matlab, if we say about hydrogen, then in case of the nature, the hydrogen will exist in the form of this as well as this. Similarly, if we talk about the chlorine, then it exists in the form of this as well as this. Okay. So, we have to consider an average of the masses they have. But here, the way of taking average will be not by like this, that average atomic mass is 1 plus 2 plus 3 divided by 3. No, this is not the correct way here taking average. Here the average is taking on the basis of the abundance. मतलब the amount of abundance they have in nature. नेचर में ये लोग कितने कितने प्रेजेंट हैं उस हिसाब से हम लोग एवरेज निकालेंगे. एंड इट्स ऑलवेज ट्रू. If I take 10 atoms in my hand and it is of hydrogen, then I will take an average of mass. In this way, average mass of them in this way if all of them are present in equal amount. But if all of them are not present in equal amount, then I will take their masses on the basis of the abundance. Okay. So, let's take an example of chlorine and hydrogen as well. First of all, take an example of the hydrogen. Okay. In case of nature, the amount of the hydrogen present in this form is almost 99%. They are, I can say that the amount of them is around 1%. So that's why the mass of a hydrogen almost come out to be 1, because their amount is negligible and their amount is 99%. But in case of the chlorine, the amount it's present in nature is around 75% and its amount is around 25%. This amount is like this. Okay. So in order to calculate the average atomic mass, what will I do is average atomic mass of chlorine is equal to 75 into 35 plus 25 into 37. It's come out to be 35.5 divided by 100 by, because it in the percentage. Now you guys will think why we have not divided by 2. If we are thinking about the percentage, average, if we are thinking about the average, then we should divide it by the 2, since there are two things. So we have to divide it by 2. But actually both of them are not present in equal amount. अगर दोनों equal amount में present होते, then we will divide it by 2. That is, they are present in 50-50%. But now they are not present in 50%. One is present in 75% and another is in the 25%, and that's why its mass number come out to be 35.5. But in case of hydrogen, what will happen is it will like 99% into 1. If I add 0.1 or something 0.001, then it doesn't matter. The mass come out to be almost 1. So that's why here there is no need to take, or we can say that if we take, then it doesn't too much matter. But in case of the chlorine, matters. And that's why in case of the many elements in the periodic table, the mass number is in the form of the decimal, not exactly in the form of the whole number. And in other elements, for example in case of the carbon, the mass number is come out to be actually 12.011. It is also in the fraction, but it's reported like 12, almost 12 it's come out to be. But here 35.5, we can't neglect the 5. We can neglect the 0, 1 because it's very small. So that's why the average atomic mass we have to consider, because in nature every element has its isotopes. So mass of each and every isotope has to be considered according to its abundance in the nature. Okay, so now we will come with the formula of average atomic mass. Average atomic mass is equal to mass of isotope multiplied by abundance of that isotope in nature, okay, that isotope plus mass of, suppose there are two isotopes of an element, mass of isotope, this is 1, this is 2, abundance of isotope 2. So this is the way of representing average atomic mass. So now let's take a quick recap what we have learned, so that we get some all the things what we have learned and come to the conclusion how this atomic mass came. So when we see the periodic table, we see two things. Atomic masses are in the form of the decimals. Second, atomic mass is in the form of the U. So we have taken actually the atomic mass in the periodic table is relative atomic mass plus average atomic mass. What is the meaning of relative? Relative that as compared to. Since the mass of the atom is very small, we consider one of the element as a reference with respect to which or with the compared to which we will get the mass of the other element. That is relative atomic mass is the mass, that is the masses of an element, or we can say that atomic mass of an element divided by 1/12 mass of the C12, and average atomic mass is the average of masses of all the isotopes which is present in nature for a particular element, and their average will be taken on the basis of an abundance. And this is actually the right way of taking an average. This average atomic mass also makes us to understand what is the meaning of an average. If we think that we are taking an average, we consider one thing. If we think that we can taking an average of two things, then we divide it by 2. If we consider that we are taking an average of 3 things, we divide it by 3. But it is actually not right. It is actually right when we say that all the 3 things or all the 2 things are present in equal amount. For example, if I say that there are two type of toffees, the red one and the blue one. Okay, the red one and the blue one. Red toffee's number is around 75% and blue toffee's number is around 25%. What is the meaning of 75% and 25%? We can say that 1/4 number of toffees are which are present in the class. If I say 100 toffees, then out of it 25 is of the blue one and red one is 75. So if I have taken average of the masses of the total toffees, then I have to consider their amount which is present in my hand or in the packet. If they are present in equal amount, then what will do? I will take the mass of this red one, this blue one, and take an average of that. But since the masses is not in the form of this, I have to take 75 into mass of the red one, 25 into the mass of the blue one, and then I get the average mass of the packet, or we can say that average mass of the packet of toffees it have. Okay, so thank you guys. I hope you understand what I have teach to you. Thank you very much.